Now for number 3 question, it says given that w is equals to x square plus y square plus z square and x, let's divide the board this way, x is equals to exponential t cos t, comma, y is equals to exponential t sin t, and z is equals to exponential t. The question says find the w dt using the appropriate chain rule. Given that we already have w, which is a function of x, y, and z, the appropriate chain rule here would be the w dt would be equals to dw dx times dx dt plus dw dy times dy dt plus dw dz times dz dt. Now finding the dw dt now using the appropriate chain rule, which is this formula we are given, which is this formula we should derive. Now first thing first, we need to get each of these variables, each of these we need to get them one after the other. Now finding the w dt, differentiating w dx, differentiating w with respect to x. Each of these are going to stand as constant values because they don't have any variable x attached to them. Now this dw dx, differentiating this with respect to x, we only have 2x. Finding the w dy, differentiating w with respect to y, x stands as a constant, z stands as a constant. The only variable we are differentiating with respect to is y. Differentiating this gives us 2y. Differentiating w with respect to z gives us 2z because x and y are standing as constants. Now we have to find the x dt. Finding the x dt means we should differentiate our x with respect to t. But looking at this, we can't differentiate this without using the appropriate product rule because we have a variable t here and a variable t here. So we call this u and call this v. So our formulas for product rule says v times u prime plus u times v prime. That is, we have v, differentiate u, and then we have u and differentiate v. Now having our x as exponential t cos t, our v is cos t, and differentiating u, exponential t, we differentiate exponential t, we still have our exponential t because we are differentiating with respect to t. Now we also have plus, our u is exponential t, and then differentiating v with respect to t because it says v prime. Differentiating v with respect to t gives us minus sine t. So our answer for dx dt is exponential t cos t minus sine t, because we take away exponential t from here and take away exponential t from here. Now for the y dt, the y dt is equals to, we are differentiating y with respect to t. We call this u, we call this v because our variable t appears here and here. So using our appropriate formula, v is sine t. We have sine t times u prime, differentiating u with respect to t gives us exponential t, plus our plus sign, our u is exponential t, and then differentiating v is cos t. So all this together, we could take out exponential t. We have exponential t into sine t plus cos t. Now for dz dt, differentiating z with respect to t. If we differentiate our exponential t, we still have exponential t because this is not the same with our exponential t cos t and our exponential t sin t. It is just a variable on its own. So differentiating exponential t with respect to t gives us exponential t. Now we'll take this and put into our expanded chain rule, which says dw dt is equals to our dw dx. dw dx gives us 2x. We have 2x times our dx dt says dx dt, and our dx dt is exponential t into our dx dt is exponential t into cos t minus sin t. Now our plus dw dy plus dw dy, our dw dy from here gives us dw dy gives us 2y into times dy dt. Our dy dt is given as exponential t, given as exponential t into sin t plus cos t, sin t plus cos t. Now let's write the other part, dw dz underneath. Our dw dz gives us 2z, and then we also have our dz dt, which is for this. Our dz dt is given as exponential t. So we could take out exponential t from here, here, and here. This gives us, we could take out 2 exponential t. So we are left with, in this part we are left with x into cos t minus sin t. And then here we are left with y and sin t plus cos t plus y sin t plus cos t. And then for this part we are left with z, we are left with plus z, and this is what we have now at this point. Remember that our x and y and z have their own values. Our value for x is exponential t cos t into cos t minus sin t, plus our value for y is exponential t sin t, exponential t sin t into sin t plus cos t, plus our z, our value for z is exponential t. So from this point we could still take out exponential t, and exponential t. This gives us 2 exponential t times, when we take out exponential t from all these parts, we have times exponential t. But multiplying these two together gives us exponential 2t. And then we are left with cos t times cos t gives us cos squared t. Cos t times minus sin t gives us minus cos t sin t. And then plus, we are left with sin t times sin t, which gives us sin squared t. Sin t times cos t gives us sin t cos t. And then we are left with 1 here, because we have taken out exponential t from everything we had earlier. Now this gives us 2 exponential 2t into, now we could say minus cos t plus sin t cos t will give us 0. We are left with cos squared t plus sin squared t plus 1, which is cos squared t plus sin squared t plus 1. Now from here we have 2 exponential 2t into, from our trigonometric identities, cos squared t plus sin squared t gives us 1 from our first trigonometric function. So cos squared t plus sin squared t gives us 1, and then we are left with plus 1. This is equals to 2 exponential 2t into 1 plus 1, which gives us 2. Therefore our final answer for dw dt is equals to 2 times 2 gives us 4 exponential 2t. So all we needed to do was examine very well, and then scrutinize on what we should do here, and pay attention to every details which will be needed to solve this. So our final answer for the dw dt is 4 exponential 2t. I hope you enjoyed the video. Do ensure to like and subscribe.